Okay, we continue our lecture with this example. This example state that during excessive physical activity, lactic acid, which is the RAM relative molecular mass is equal to 90.08 forms in muscle tissue and is responsible for muscle soreness. Elemental analysis show that this compound contains 40% mass carbon, 6.71 mass percent hydrogen and 53.3 mass percent oxygen. And the question asks you to determine the empirical formula of lactic acid and the molecular formula. Okay, first step, you need to write down the percentage. So the percentage already referring to the mass. Okay, 40%, 6.71%, 53.3%. And the amount of the mole of the element is a mole equal to mass over molecular mass. For carbon is 12. Then you get 3.33. Here is 6.71 divided by the mass, molar mass of hydrogen is 1. You get 6.71. And here is oxygen. The mass is 53.3 divided by 16 is the molar mass. Then you get 3.33. And here you get 1, 2, and 1. And to calculate the empirical formula, so the molar mass is 90 divided by 30. Empirical formula mass, then you get 3. Then here you need to times with 3. And this is the final answer for molecular formula. And here you can go through by yourself. Okay, what is the combustion analysis? Combustion is referring to the train for determination of the chemical composition of organic compounds. And the unknown compound is burned in pure oxygen here. And then all the hydrogen in the unknown is converted to H2O, which is absorbed in the first chamber. And all the carbon is converted to CO2 and is absorbed in this second chamber. And by weighing absorbers before and after combustion, we find the masses of CO2 and H2O to calculate the mass of carbon and hydrogen. This is the sample problem. A dry cleaning solvent equal to the molar mass is total 146.99 gram per mole, contains carbon, hydrogen and chlorine. When a 0.25 gram sample was studied by combustion analysis, 0.451 gram of CO2 and 0.0617 gram H2O is formed. Find the molecular formula. So the solutions are, you need to find the mass of carbon, hydrogen and chlorine. Then this is basically the mass of carbon dioxide divided by, this is the RMM, molecular mass for CO2, times this is the molar mass for carbon. Then you cancel this unit, cancel, and cancel this unit. Then you get 0.123 gram carbon. Same goes for hydrogen. And to calculate the mass for Cl, the total mass for a sample is 0.25. You need to minus by 0.123 plus 0.0069. Then you get the mass for chlorine is 0.1201. Then you need to determine the empirical formula for carbon, hydrogen and chlorine by using this step. This is the simplest ratio of the relative amount. Here is the empirical formula. And to calculate the molecular formula, same as a previous solution. So you need to times with 2 because here is 2. Then you get C6H4 Cl2. And for the learning objective for today, we move to stoichiometric problem. So name and write formula of simple inorganic compound, name and write formula of binary covalent compound, name and write formula of simple acid, bases, and hydrate, determine empirical and molecular formula of unknown compound. This we already achieved. And for today, learning objective for number 5, we need to know how to solve the stoichiometric problems involving limiting reactant. So today I will discuss about chemical reaction and chemical equation. So what is a chemical reaction? Chemical reaction is a process in which a substance or substances, more than one, is changed into one or more new substance. Involve a reorganization of atoms in order or more substances. Standard way to represent chemical reaction is by using chemical equation. For example, here is the reactant. When sodium react with Cl2, and at the end of the reaction, it will produce sodium chloride. This is the product of this reaction. Plus is mean by sodium react with. The arrow means that it produce or yield. And what is S and gram? S is referring to phase label which indicate physical state. S is solid, sodium in solid form, while G is chlorine in gas form, and S here is sodium chloride in solid form. And for a chemical equation to be balanced, it must have the same number of each type of atom on both sides of the arrow. Means that the number of carbon at the left side of the reaction should be same. Same number for the carbon at the right side of the reaction. So interpretation of balance equation, for example, at microscopic level, you have one molecule react with a two molecule to yield one molecule plus two molecule water. So one molecule methane react with two molecule oxygen to produce one molecule HCO2 plus two molecule of water. At macroscopic level, 1 mole, 2 mole, 1 mole, and 2 moles. Macroscopic moles, microscopic molecule. So, or the number of atom is equal to 6.02 times to the number of Avogadro, Na. So, times to the power of 23 molecule. So, you get here is 16.04 gram. Here is 2 times 2 because here is n times 2. Here is just 1 mole. 1 mole equal to 6.02 times to the power of 23. Here is Avogadro number. Here is times 2 molecule. And here is 16.04, 64, 44, and 36.03. Here is the RMM, molecular mass for oxygen basically. 16 times 2 is 32. 32 times 2 is you get 64. Basically 16.04, 64, 44.01, 36.02 is referring to molecular mass of each molecule. Step for balancing chemical equation. Write the unbalanced equation. Determine what coefficient are necessary. Start with the most complex substance and end with the least complex substance, specifying states of matter. And this example, ethane is a gas which burns in oxygen to give carbon dioxide gas and steam. The steam is simply water in gaseous form and condensed to form water droplets. Write a balanced chemical equation for this reaction. Ethane react with oxygen to produce carbon dioxide plus H2O. Then you need to balance the stoichiometry of the reaction. Basically, here is 7 divided by 2, then you cancel the unit. And here you times with 2, 3. Then here you get 7. Here is 2. 2 times 2, you get 4 and 6. Okay. Then at the end of the final answer, you need to put the phase of each molecule. This is gas phase, gas phase, gas phase, and liquid phase. For the exercise today, you need to balance the following equation. Please do and share in your Padlet and share with me in my Padlet today for this exercise. And we continue to calculate the amount of reactant and product. In a balanced equation, the number of mole of one substance is stoichiometrically equivalent to the number of mole of any substance. And the coefficient tells us mole ratio of reactant that correctly react to form product. So how to solve stoichiometry problem? First, you need to write down the balance equation. After that, you need to convert mass to mole. Then you need to use mole ratio. After that, you need to convert mole to mass. And here is the mass, convert to the amount. And molecule, here is amount. Mass to amount or amount to molecule. You can use either Avogadro number here. For example, here the question asks you to calculate how many moles of oxygen are required to roast 10 mole of copper sulfide. And question 2 is how many grams of sulfur dioxide are formed here when 10 mole of copper 1 sulfide is roasted. So about 10 mole of copper sulfide times 3 mole of oxygen divided by 2 mole copper sulfide. So then you get 15 mole oxygen. Basically, you need to balance the stoichiometry first. After that, how many grams of sulfur dioxide are formed when 10 mole of copper 1 sulfide is roasted? So here is 10 mole copper sulfide, 2 mole sulfur dioxide, 2 mole copper sulfide, and here is 64.04 SO2. Here is referring to molecular mass of sulfur dioxide. 1 mole sulfur dioxide equal to 64.07 grams sulfur dioxide. This is referring to molecular mass. And how to get this one? You need to write down the balance stoichiometry here first. Then at the end of the calculation, you get 641 grams sulfur dioxide. This is the exercise. The exercise asks you to calculate the mass of CO2 is formed in the reaction of 4.16 gram triethylene glycol with an excess of O2. And number 2 is what mass of O2 is consumed in the complete combustion of 6.86 gram of triethylene glycol. Cuba you buat yang ni dulu, nanti tak faham tanya saya. Okay. And the limiting reactant, sometimes when a chemist carry out a reaction, the reactant are usually not present in exact stoichiometric amount in the proportion indicated by the balance equation. This means some reactant will be used up when other will be left over at the end of the reaction. And the reactant that will be used up is the limiting reactant. Maksudnya reactant yang telah digunakan secara dah habis lah. Reactant tu kita panggil limiting. And the reactant that will be left over, maksudnya reactant yang masih lagi tertinggal, ada masih lagi berbaki, kita panggil excess reactant. Here is the excess reactant because here katalah kita kira sini ada berapa yang biru ni. 1, 2, 3, 4, 5, 6, 7, 8, 2, 4, 6, 8. Here is 2, 4, 6. So the blue color, it has 8 And here the smiley 1, 2, 3, 4, 5, 6. Smiley is a limited one. So it is referring to limiting reactant. And the importance of limiting reactant is the amount of product formed is determined by the limiting reactant. Here is the balance for the excess reactant. And stoichiometry involving limiting reactants. What mass of H2O can be produced by 4 gram of H2 reacting with 16 gram of O2? What mass of excess reactant is left after the reaction? Okay. Hydrazine N2H4 and dinitrogen tetroxide ignite on contact to form nitrogen gas and water vapor. How many gram of nitrogen gas form when 1 to the power of 1 times 10 to the power of gram of N2H4 and 2 times to the power of 2 gram of N2O4 are mixed. So here you need to write down the balanced chemical equation. So you need to make sure the stoichiometry is balanced. After that, you need to find the mole of N2 from N2H4. So 1 times to the power of 2 gram N2H4. 1 mole N2H4 equal to 32.05 gram N2H4. This is referring to molecular mass for N2H4. 14 times 2 is 28. 28 I think. 28 plus 4 is 32. Almost 32. Then you cancel the unit here, gram and gram. Then you get the number of mole of N2H4. And step number 3 is you need to find the mole of N2, nitrogen in the dinitrogen oxide, here N2O4. So basically here is 2 times to the power of 2 gram N2O4. Here is the molecular mass for N2O4. Then you get the number of mole N2O4. So the 2.17 here is referring to mole of N2O4. How to get this one? This one is referring to 3 is the stoichiometry. Okay, in 1 mole of N2O4, you have 3 mole of N2. So you get here 6.451 mole N2. After that, N2H4 is the limiting reactant because it produces less product N2 than does N2O4. And step number 4, you need to find the mass of N2. So here is 4.68 mole N2. Cancel and cancel, then you get 131. How to get 131? 28.02 times with 4.68. You get 131 gram N2. Okay, to calculate the percentage yield, so A plus B reactant, then you get the main product C and the side product is D. The effect of side reaction on yield. And to calculate the percentage yield is the measure of productivity of the reaction. Percentage yield is equal to actual yield divided by theoretical yield times 100%. What is actual yield? Actual yield is the actual mass obtained in a real experiment. Theoretical, or we call as a calculated yield, is amount under perfect lab condition. Normally, percentage yield may range from a fraction of 1% to 100%. Chemists strive to maximize percentage yield in a reaction. This is the sample problem. Okay, marble, calcium carbonate, react with hydrochloric acid solution to form calcium dichloride solution, water plus carbon dioxide. What is the percent yield of carbon dioxide if 3.65 gram of the gas is collected when 10 gram of marble react? First, you need to write down a balanced equation. Means that you understand here CaCO2 react with hydrogen chloride in the aqueous solution to form CaCl2 in aqueous because it states here solution plus water you put in liquid form and CO2 gas form. Then after that, to calculate the theoretical yield, about 10 gram times in the 1 mole of calcium carbonate, you have the 100.09 gram. This is referring to molar mass of calcium carbonate. And 1 mole calcium carbonate equal to 1 mole CO2. This is referring 1 and 1 referring to stoichiometry. And here 1 mole CO2 equal to 44.01. Here is referring to molar mass. Then you cancel the unit, you get 4.4 grams CO2. And the percentage yield is 3.65 gram in the question given, divided by this is the theoretical yield times 100%. Then the value is 83%. Okay, here is 34.6 gram of silver was reacted with excess sulfur according to the following reaction. So 24.8 gram of silver sulfide was collected here. What are the theoretical yield, actual yield and percentage yield? What is the mole of silver equal to mole mass over molecular mass? What is the mass for silver? Is here 34.6 divided by 107.87 is referring to molecular mass of silver. Then you get 0.320 mole. And for the mole of silver sulfide produced, so mass over molecular mass, mass over molar mass. Okay, what is the mass for silver sulfide is this is not a mass, this is the mole. So you want to get the mole. So basically here is mole of silver. So 0.3208 mole of silver divided by 2 mole of silver in this reaction, the stoichiometry. Then you get how many mole here is referring to 0.1604 mole of silver sulfide. So the theoretical yield is equal to 0.1604 is the mole for silver sulfide times 107.87 is the molar mass for silver times 2. Why you need to times 2? Because here is 2 plus 32.06. 32.06. Okay. So you get 39.73. And the actual yield is 24.8 gram here. How to calculate the percentage yield? Actual yield divided by theoretical yield is here 39.73. Then you get 62.4% is for the percentage yield.